This video is going to introduce the topic of methods, more specifically how we can write our own methods. So what is a method? Well, methods can be used to break a complex program into smaller pieces. If you think back to our algorithm days, when we discussed that at the beginning of the semester, we talked about sub-processes and processes. A method is kind of what that translates to in a program. We have two different kinds of methods. We have a void method, and we'll discuss these more in depth. But a void method simply executes a group of statements, and then it will terminate. We also have methods that return values to the statements that call them. So far, we have used methods in two primary ways. The first way is we've created a method named main in every program we've written. That's that main method. And if you remember, the main method is a void method, right? Public static void main. So we've created a main method. And we've also executed predefined methods from the Java API. So we've executed system.out.println. In that case, it would be the println method. We've executed the power method from the math class. We've executed some of the scanner class methods. Last week we discussed the JOption pane methods, the random class methods. We've used all kinds of methods that have already been written for us. So why do we care about using methods? Well, instead of writing one long method that contains every statement necessary to solve a problem, we can write several smaller methods that each solve a specific part of the problem. Again, going back to that sub-process idea from an algorithm. The methods that we write can then be executed in a specific order to solve the problem. And we call this the divide and conquer approach, which is used to divide a large problem into several smaller problems that are more easily solved. So here's an example. Over here on the left is kind of what we've seen so far. We have a main method, and we do everything we need to do in our main method, right? We just execute one statement after another until we finish the problem. Over here is how we could kind of divide this problem. We still have a main method, right? But we can see that it's much shorter. And instead of doing everything in the main method, maybe we split that work up into some smaller methods. Methods have another benefit. We call that code reuse. If we need to perform a specific task in several different places in our program, we could write the method one time and then call that method as many times as we need to. So like I said, we write the code once and reuse that code each time the task needs to be performed. So let's talk a little more specifically about the two different types of methods that we have. We have a void method, which is one, like I said, that simply performs a task and will terminate. We also have value returning methods. These methods not only perform tasks, which they do that, but they also send a value back to the code that called that method. So if you think back to the scanner methods, right? And I'm going to try to, we'll see if we can do this. I could say something like int x, and we'll pretend like this is legible, receives kb dot next int. Right? We've written this statement several times. Next int is the method, right? This is an example of a value returning method because we're returning a value and we are assigning the value that we return to this variable, right? And we'll get more into value returning methods here in a second, but we have seen those. And like I mentioned earlier, we've seen void methods with our main method, right? Public static void main. The main method does not return a value. It's just going to execute these statements one after another, and then it will terminate. So let's take a look at a void method here. Oops. So the printline method, right, is a good example of a void method. All the printline method is going to do is it's going to print some value or display that value to the screen, and then the printline method terminates, right? I'm not assigning a value that comes from printline to anything. I'm just calling it. It's going to display the number and it's going to terminate. And then we could resume our code further down in our program. A value returning method, like I just showed with my very good handwriting, is something like this. Rand.nextInt is a value returning method. It's returning a random value. Where are we going to put that value that we're returning? Well, in this case, we're going to assign the returned value to the number variable. So nextInt, the method, executes, it returns a value, and then we assign that value to the number variable. So how do we actually define our own methods, right? Because these examples here, printline, nextInt, all of these methods have been pre-written for us, right? They're already written in the Java API. All we have to do is just call them by their name, and then we can use them. But what if we want to write our own method? Well, to do that, we have to write what we call the method definition. And the method definition has two parts. We have a method header, and we have the method body. The method header lists several important things about the method, including the method's name. So what we're going to call the method, that's also listed in the header. And then the method body is a collection of statements that are performed when that method is executed. So think back to your main method, right? Public static void main, string with the brackets args. That's our method header for the main method, right? The method name is main. The method body with the main method is whatever we want to execute for our program. So here's an example of a method header. These first two attributes here are called method modifiers. This one here is the return type. Then we have the name, and then we have parentheses. So just like we've seen with main, public static void. So these will always, for the most part in 1250 until we get towards the end, our first two method modifiers will always be public static. Our return type may change, but for now we're going to use void for this example, and then whatever we want our name to be. And then the parentheses have to go at the end. And remember, the main method has stuff in these parentheses, right? We have string, bracket, bracket, args. This method, you'll notice, has nothing in the parentheses, and we'll discuss what that means here in a sec. And then down in the method body, right, we would have whatever statements we want this method to do. And just like every other structure body we've talked about, it is denoted by these curly braces. So an opening curly brace, a closing curly brace. Everything in between is our method body for this method. So the different parts of the method header, our method modifiers, right? That was that public static. The word public means the method is publicly available to code outside of the class. The word static means the method belongs to the class, not a specific object. And like I said, toward the end of the semester, maybe into 1260, you may not really understand what public and static are actually doing. So for now, just kind of remember those will be our method modifiers. The return type, when the keyword void appears here, it means the method is a void method, which means it does not return a value. And we'll see what other return types we can use further along. Method names, you should give each method a descriptive name. In general, you want to apply the same naming rules to methods that you use with variables. So if you remember, our naming conventions are camel case with our variables. So we capitalize every word except for the first one. Parentheses, the method name is always followed by a set of parentheses. Any arguments that the method receives will appear inside of these parentheses. So once we've written a method, right, how do we actually use the method that we wrote? Well, we need to call it, just like we call kb.nextInt or jOptionPane.showMessageDialog. Those are method calls. How do we call a method that we write? Well, we say a method is executed when it is called. The main method, which is why it's so important to have one, is automatically called when a program starts. That's just something Java does. It looks for the main method and it calls it so it's automatically executed. Other methods are executed by method call statements. So this is an example of a method call statement to the display message method, which is the one we looked at just a second ago right here, right? This is how we would call display message in our program. The call statement is simply the name of the method, followed by a set of parentheses. And because this is considered a complete programming statement, we terminate it with a semicolon. So you may notice, why do we not have anything before the method, right? Like we're used to seeing like kb.displayMessage or jOptionPane.showMessageDialog. We don't put that there because this method belongs to our class, right? We wrote this method ourselves. It is inside of our own file, so we don't have to provide a path to it because it's in the file that we have created. So I'm going to show a code example of kind of a basic example of how to create and call a method. So I've already written the skeleton of this code, so I've got my class header, I've got my main method here, and just a few comments. So if we want to have this do something, the first thing I'm going to do is I'm just going to say hello from the main method. All right, so this statement kind of tells me I'm in the main method because I've chosen this statement. Now let's say I want to write my own method here. So I'm going to say public static void display message. And this should look familiar. This is from the slides, right? This is the same method that I showed in the slides. I'll give this a little comment. And let's have display message display something to the screen. So here I'll say hello from the display message method. Now, like I said, if we want to use this method, right, we have to call it. And we have to call it up here in our main method. So I will say display message, parentheses, semicolon. So what my program will do is the first line it will execute is this one, which will display hello from the main method to the screen. Then it will execute this method call. Once it sees this method call, it's going to look for this method, which is here, and it's going to execute any statements inside this method. So it's going to execute this statement, and then it will come back up to the main method once display message is done, and we can have it do something else after just to show that it did come back. And I think I might have this just say back to the main method. All right, so this is a pretty simple example. So we will run this code. We see our first line is hello from the main method. Our second line that's displayed is hello from the display message method. And our third is back in the main method. Right, so when I call display message, any of its statements will be executed, and then we will kick back up to the main method once display message is done. Right? We could also do some logic, so I'm going to show another example here. I'm going to import scanner. I could use jOptionPane for this, but I think I'm just going to use scanner instead. So let's look at a more applicable example here. I'm going to create some variables. I'm going to create a scanner object. I'm going to get the user's annual salary. All right. And this should be next double. Then I'm going to get the user's credit rating. So far all of our work has been in the main method, right? And now we can do a little bit of logic here. So we can determine if the user qualifies for the credit card. This example should look a little familiar. We did this one before when we talked about if statements. So I can say if salary is greater than or equal to, and we'll say they need $20,000 to qualify, and they also need a credit rating of at least, we'll say 7. Oh, I never actually assigned to credit rating. So here, credit rating would receive kb.next double. All right, so let's say here, I want to call a qualify method if they do qualify. Here I will call a no qualify method if they do not qualify. So I do need to write these methods, right? So this is the end of the main method. So I could write a public static void qualify. And I'll write another one, public static void no qualify. So this method will display a qualification message. This method will display a non-qualification message. All right, so again, these will be pretty simple statements or simple methods. So we'll say that's our message for if they do qualify. If they do not qualify, we'll say, sorry, you do not qualify for the credit card. All right, so we've written our methods. Now if we go back up here, we can say, we'll call the qualify method. If they do not qualify, we will call the no qualify method. Right? So if we were to run this code, let's put in something that we know does not qualify first. So we'll say we make $500 salary and our credit rating is 1. So we'll see, sorry, you do not qualify for the credit card. If we put in something we know will pass, we'll see, congratulations, you qualify for the credit card. So we wrote 2 methods and we called them. Something else we can do is we can actually call a method inside of a loop. So let's say that I just want to hello from the main method. Let's say I want to call a method a bunch of times. So I could say something like this. Let's just say I want to loop 5 times. And I'm actually just going to copy the display message method from earlier, just to save some time. All right, so I'm calling a method each time I iterate in a loop. That's not the program I wanted, this one. So we'll see I have hello from the main method. I have hello from the display message 5 times because our loop is looping 5 times. And then once that's done, I will display back in the main method. So just some different ways you can call methods, right? You can just call them outright. You can use some logic to determine which method you want to call, or you can call them recursively in a loop. All right, so we also have the concept of layered method calls, which means method A can call method B, and method B could then call method C. When method B would finish, the program would return back to method A. So I have an example of this called deep and deeper. So I'm going to write 2 little empty methods here. All right, so I've got 2 methods. We'll say, I'm going to put a comment here. This method displays a message and calls the deeper method. All right, so let's say I'm going to just leave a message here to show you how this works. So I am starting in main. And then in deep, I will say I am now in the deep method. Deeper will say something like I am now in the deeper method. So what makes this recursive? Well, if I have the main method call the deep method, and I have the deep method call the deeper method, what will happen is this. So the main method will display this message. It will call the deep method. So we'll go to the deep method. This message will be displayed, and deep method calls the deeper method. So now we'll travel down to the deeper method. This message will be displayed. Nothing else happens here, so I will kick back up to deep, and then I will kick back up to the main method. So let's put something after our call here just to show that kick back up process. We'll say I am back in the deeper, or the deep method. And then here we will say I am back in the main method. So we can kind of see how this works. Our first statement says I'm starting in the main method, which lines up with what we have on line 13. On line 14, we call the deep method. So we'll go down here and see what that does. Line 23, our print statement says I am now in the deep method. So we'll see that that indeed worked. Line 24, we call the deeper method. So let's go down here. The deeper method says I am now in the deeper method. So we'll see that is working. Now we're going to kick back up to after this method call. Is there anything else that happens? Yes, we have one more print statement. I am back in the deep method. We'll see that is working. Once our deep method terminates, we'll go back up to right after the method call in our main method. And we will see we have one last print statement that says I am back in the main method. The main method terminates and our program finishes. All right, so that's the concept of a layered method call. You can have methods that call other methods. So let's talk about passing arguments to a method. We've actually used method arguments before, and those are just simply any value that we send to a method. So system.out.println has one argument, and we've seen this before, hopefully, and that is the message that we want to print to the console, right? So hello here, this hello string literal is my argument. So why are arguments being discussed here? Well, we have a concept called a parameter variable, and that is a special type of variable that holds a value being passed into a method, right? What values are passed into methods? Well, those are arguments, right? We just discussed that. So parameter variables are used to store arguments. So here's a little example. Let's say I want to display a value. Here I have written a parameter variable, right, inside the parentheses. The code examples we've seen so far did not have anything inside the parentheses when we wrote our methods. This one does. So our parameter variables go inside the parentheses. And we declare these just like every other variable. We need to give it a data type, and we need to give it a name. And then in our method body, we can actually use the value of that argument that was passed to the method. The value of the argument is being stored in the parameter variable, so that's how we reference it. All right, so let's say that I call display value. I'm just going to put dv here. Let's say I call display value and I pass in a value of 9. All right, so this is my method call. So what this method will do is num, right, will store that argument. My argument in this case is 9. Num now stores 9 while this method is being executed. So my print statement says the value is, what is num? Well, it is 9, right? It's based on whatever we pass as an argument. So here's another example. Display value, I pass in 5 as an argument. The argument 5 is copied into the num parameter variable, and then it would be displayed to the screen. We talked about scope, right? Variable scope. A variable scope is the part of the program where that variable may be accessed. So if you remember, control variables in loops can only be accessed inside those loops. So like if I go back to here and I were to come up here, if I try to access this control variable anywhere outside of this for loop, that is outside of its scope, right? We've talked about scope. So do parameter variables have scopes? They do. And the parameter variable's scope is only the method in which that parameter is declared. No statements outside the method can access the parameter variable by its name. So let's do a pretty simple example of how to pass an argument to a method. So I'm going to go ahead and write the method first. So instead of saying display message here, I'm going to say display value. And I want to create a parameter variable here. I'm just going to call this int num, just like from the slides. And I just want to display the value of num. So I'll say the value is, and I'll display that to the screen. So let's come up here and say int x has an initial value of 10. And let's just start passing things to that method and seeing what happens. So 5 is my argument here, And IntelliJ is actually kind of nice because it shows you the parameter name, right? So num is the parameter name. If I were to change this to something else, we'll see that IntelliJ actually shows me what that parameter is called, which is nice. So I'm going to call this and pass in 5. I'll call it again and we'll pass in x, which we see we can pass in variables as our arguments, right? So x has a value of 10. If I pass in x, that's the same thing as passing in the number 10. I'll pass in x times 4, right? Because 10 times 4 is still an integer, so that will work. And I'll pass in something that we just learned about. So I'll pass in integer.parseInt, and I'll try to pass in the string 700. All right. So what should happen is my main method is going to call the displayValue method, and it will just display the value of each of these arguments, right? And remember, the arguments are stored in the parameter variable num while the displayValue method is being executed, right? So the first time I call it, num stores a 5. The method terminates, so num's scope has died. Num is no longer in existence. Then when I call displayValue and pass x, num is brought back. It's going to store whatever x has in it, which is 10. It's going to display x, and then it will die. I call it again, it stores x times 4, displays, and dies, so on and so on. So you can reuse parameter variables like that. So I'm going to run this, and we'll see our first argument was indeed 5, so that looks good. Our second argument was x, which is storing 10, so that looks good. Our third argument was x times 4. 10 times 4 is 40, that looks good. And our final argument, we parse the string 700 into the integer 700, so that works. So that's kind of how we can pass values to methods. Can we pass multiple arguments? We can do that. It's often useful to pass more than one argument. If you want to pass multiple arguments to a method, you need to create multiple parameter variables to store those arguments. So this example here is a method that calculates a sum, right? So one of our parameters is called num1, and it's a double. Our other parameter is called num2, and it's also a double. And what this method will do is it will calculate the sum of my two arguments, which are being stored in these parameter variables, and then it will display that sum to the screen. Because we have two parameter variables, that means we need to keep that in mind when we call showSum, right? We need to have two arguments as well, separated by a comma. So I'll do that. I'll write that method here. I'll say public static void showSum. I'm just going to make these ints just because I can say sum receives num1 plus num2. And then I could display that. And I could actually write this out a little bit better if I wanted to. I could say num1. I could write this out like a mathematical formula. Right, and that would display it. So I can calculate, or I can call this method up here. ShowSum, I'll do x as my first argument, and I'll do x times 2 as my second argument. And we can run this, and we'll see 10 plus 20 is 30, as my print statement says here. All right, so that's kind of how multiple parameter variables can store multiple arguments. So here's some more stuff about parameter variables. Every parameter variable needs a data type, right? We're declaring variables. We cannot declare a variable without a data type. Unfortunately, with parameter variables, if these are both doubles, we can't do this like we could in a regular declaration statement, right? Each parameter has to have its own data type listed next to it. So even though these are both doubles, you need to put double next to both of them. So how do we pass object references to a method, right? Like strings, things like strings. Remember that a string object or a string variable is referencing a string object, right? That can be a little confusing, but the name variable here references an address. That address points to some string object that has a value, right? Just like we talked about reference variables. We can pass those reference variables as arguments, though, and that's totally fine. So if I wanted to pass name here into my showLength method, that would work. I can use that reference variable as a argument, and Java is smart enough to find where that reference is pointing to and use that string value in its string calculations. So let me show an example of that. So here I have a method called passString, and this is really showing you that you cannot change you can't change the value of a string argument, right? Because it is a reference variable, right? You're not actually changing the value of the object itself. You're changing the value of the reference. So this will make more sense in a sec. So I'm going to write a method here called public static void change name. And like I said, with all parameters, we need a data type and a name. And I could say something like this. I want to change the value of my reference variable to Dickens. Right, so what is this method trying to do? Well, we want to create a string object containing the word Dickens, and we want to assign its address to the parameter variable str. That's what we're doing, right? We're creating a new string object that contains the word Dickens, and we are assigning its address to str. So up in our main method, let's create a new string object called string name, and we will give it a value of Shakespeare, and we will assign its reference to this reference variable here called name. Hopefully these comments are useful and not distracting. Okay. So let's go ahead and display the value of that string referenced by the name variable. So display the string referenced by the name variable. So I can say something like this. In the main method, the name is whatever that reference variable points to, right? Then we can say, I'm going to call the change name method, passing the contents of the name variable as an as an argument. So I'm going to call the change name method. It expects something, right? I'm having a little error here because it's telling me, hey, I'm expecting a string. You wrote a parameter variable. You need to put something in here as an argument. So my argument in this case will be whatever name, whatever address name has stored. Right? Because if you think about address variables as pointing to a location in memory, name is pointing to some string object that says Shakespeare, right? If I pass that address here, right, what happens if I try to change what that address is pointing to, right, like I'm doing here? So if I try to change that, will name now point to a string that says Dickens, or will it still point to a string that says Shakespeare? Well, let's find out. So after I call this method, it's going to kick me back up to the main method, right? So we'll see if it's Dickens in change name, we'll see if it's still Dickens back in our main method. And I'm just going to copy this here. So let's see if this actually changes what name is referencing. And I'm getting some ugly networking issues here, but we can see in the main method, the name is Shakespeare. In the change name method, the name is Dickens. Back in the main method, the name is Shakespeare, right? So why is this doing this, right? Why is this not changing Shakespeare to Dickens in the main method? Well, the reason it's doing that is because str, whatever value it has, right, which it had the address that name had in it, we're overriding that value here, right? We're saying str now contains the reference to a brand new string object, completely different from the one name is referencing. And this new string object says Dickens. Once this terminates, that reference to Dickens is gone. Once we get back up here to the main method, name still references a string that says Shakespeare. So that's why it doesn't change that value. And if you want to think about it this way, this is a perfectly legal programming statement. You could write it like this, right? Since str is referencing a new string object, the way that I had it is just the shorthand, right? This is just a shortcut way of saying str is assigned a reference to a new string object. It's kind of a shortcut. So, kind of confusing, but just keep that in mind. Let's talk about local variables. And we discussed local variables, excuse me. We discussed local variables a few weeks ago, and we said that a local variable is any variable created inside a method. We call them local because they are local to the method in which they are declared, right? So any variables I create in my main method are local to the main method. I can't use them outside of the main method. Local variables are hidden from other methods, and they only exist while its method is executing. So what does this mean? Well, if they're hidden from other methods, that means that different methods can have their own local variables with the same name. I could have int x in my main method, and I could have it in method A. I could have int x in method B. I could have int x in method C. It doesn't matter if they have the same name because they're hidden from the other methods, right? And the fact that it only exists while its method is executing, we call that the lifetime of the variable. So just like I was mentioning earlier, when change name, when this method terminates, any variables I use in change name die, right? The lifetime of str is over once change name terminates. So let's do an example for local variables, and then we'll talk about returning values. So I've got a file here called local vars. This is going to go over some things about local variables. So let's say I have a method. I'm going to call two methods. I'm going to call one called Texas, and I'm going to call one called California. I don't have these methods yet, right? So it's going to be upset with me, but I'm going to write them now. So here's my Texas method. Let's say I have an int called birds, and let's say it has a value of 5,000. And I could say something like, in Texas, there are, I'm just making this up, there are this many birds, right? And I'll leave a little description here. So the Texas method has a local variable named birds. Now I'll write the California method. I'm going to make a new variable called birds, and I'm going to give it a value of 3,500. And I'll leave a description here that says the California method has a local variable named birds. And I'm going to change this a little bit. All right, so we can see that I have two variables named birds. They're named the same thing. But that's not a problem, right? Because the scope of Texas birds is the Texas method. When this method is done, its birds variable dies. California's birds variable has a scope of the California method. When California finishes, its birds variable dies, right? Now where we have the problem, which we may have seen before, is if we try to declare a variable twice in the same method, that's a problem, right? Because the scope of this birds variable is main. The scope of this birds variable is main. We can't have two variables in the same scope with the same name, right? So that's where it can give you errors. So if I were to run this code, we'll see that these two birds variables do not conflict with each other at all. They're completely different variables, even though they have the same name. All right, so let's talk about returning a value from a method. We know that data can be returned from a method back to the statement that called it. We call these methods value returning methods. For example, the math.pow method, right? It gives you an exponential power. So this method call raises 4 to the power of 2 and returns it to something, right? We have to return it to a statement that calls it, right? We're calling math.pow. Where are we going to put that return value? Well, we can assign the return value to a variable, right, in order to actually have that 4 to the second. So if we want to define a value returning method, right, we've talked about void methods so far. There's two things we want to keep in mind with value returning methods. The first thing, we replace the void keyword with whatever data type we're going to be returning. So in this example, sum is returning an integer. So instead of saying public static void sum, I say public static int sum. And the second thing we want to keep in mind is the return statement, which we'll talk about here in a second. So the return statement, you have to have a return statement in a value returning method. You must have a return statement in a value returning method. That's very important. If you don't have this return statement with the return keyword, right, you'll get an error. Your code won't compile. Because when you say public static int, Java looks for, okay, you're saying you're going to return an integer. Do you actually return an integer in this method body, right? So that's why you need the return statement. The return statement causes the method to end execution, so that's why we put it at the end of the method, and it returns a value to the statement that called the method. And we can return any expression that has some kind of value, right? So I can return a variable, I can return a literal, or I can return mathematical expressions. Like here I'm returning a mathematical expression between two variables, right? I can do that because num1 plus num2 will eventually equal an integer, right? Once those are added together, it will be an integer that'll work out. The data type that is returned must match the data type of the variable that receives the value. So if I say I'm returning an int, I better return an int, and whatever I try to store this return value in also needs to be an int, right? So let me show an example of a value returning method here. So I'm going to go ahead and define some variables in main. I'll say int value 1 has a value of 20. Value 2 can have a value of 40, and total will not have an initial value. So what I want to do is I want to call the sum method. All right, so I'm going to call the sum method, and I'm going to pass in value 1 and value 2 as my arguments. Then I want to assign whatever the sum method returns to the total variable, okay? So I guess the first thing I would want to do is actually write the sum method, right? So I'm going to say public static. This is a value returning method, right? So it's not void, it's going to be int. I'm going to have two parameter variables to store my two arguments. I'm declaring a local variable here. We'll see that I have an error. If I hover over that error, IntelliJ is telling me, hey, you're missing a return statement, right? So I'm going to have to put my return statement in here eventually. So there's two ways I could do it. I could say result receives num1 plus num2, and then I could return the value of result. Or I could take a shortcut and eliminate the result variable entirely and just return num1 plus num2. Both ways are perfectly valid, it's just kind of personal preference. Now, here's a good opportunity to talk about documentation. Coding standards so far, we've talked about the file documentation and the class documentation. All our method documentation has been is this right here, right? We just say the words main method. Now that we actually are writing some more complex methods, I want to show you how an easy way to actually generate this documentation. So if you hit / and 2 stars in IntelliJ and hit enter right above your method header, it will generate most of this for you. Okay. And all we have to do is just go in and fill this out pretty much. So the first line is what the method does. So the sum method returns the sum of its two parameters. Right, pretty simple. The @param keyword tells you what are these parameters representing, right? So num1 is the first value to be added. Num2 is the second value to be added. And return is the sum of num1 and num2. So the @return keyword here asks you to describe what you're returning. And that's all you have to do for method documentation. So in these methods, right, I did document these. You'll notice the / and the 2 stars. In void methods with no parameters, your method documentation can be as simple as this. But if you have parameters or if you have arguments, you do need to sort of define those. So here, for example, on that change name method, / 2 stars, I could give it a description, and I could describe that parameter. All right, and you'll want to do that on all of your methods. And I'll go back through and do that on my methods after the video, just so that you have some good examples of what method documentation looks like. So now that we've written the sum method, right, we are returning whatever value this ends up being. Num1 plus num2 will evaluate to some integer value. I'm going to return that value back to the main method. And since I'm returning it, I need to store it somewhere, right? It's like throwing a baseball. Sum is throwing an integer baseball at the main method. Something needs to be here to catch it. Well, luckily we've created a variable called total that can catch that returned value. So total receives the returned value of sum, and sum is expecting 2 arguments, in this case value 1 and value 2. Right, and I could display that if I wanted to. So display the value of the variables. So I could say value 1 plus value 2 equals total. All right, so value 1 is 20, value 2 is 40. Our sum should be 60. So if I run this code, we'll see 20 plus 40 equals 60, which is based on this print statement here. All right, so we returned whatever the total of these two numbers are. We stored it in a variable, and we displayed it using a print statement. So that's how return types work. Some common things to avoid when you're working with methods. Putting a semicolon at the end of a method header, you don't want to do that. So that would be like trying to put a semicolon here at the end of the main method. That doesn't go there, and a semicolon wouldn't go like on method headers you create yourself. They don't need them. They need curly braces, but not semicolons. Writing modifiers or return types in a method call statement. Forgetting to do that, right? You need to do that. Forgetting the empty parentheses in a method call that accepts no arguments. Forgetting to actually pass arguments to methods that require them. Passing an argument of a data type that cannot be converted to the data type of the parameter. So if your parameter variable is a integer and you pass in the word cheese as an argument, that will be an error. Attempting to access a parameter variable with code outside the method that the parameter variable is declared in. Remember scope. Not writing the data type of each parameter variable in a method header. Your parameters need data types. Every parameter variable has to have a data type. It's important, and they're separated by a comma. Using a variable to receive a method's return value when the data type of the variable is incompatible with the data type of the return value. So if I'm returning the word apple from a method, I don't want to try to store the word apple in an integer variable. right? I would need to store that word in a string variable. And the last common mistake with methods is forgetting to write your return statement in a value returning method. So that's all I have for methods. We will be using methods kind of extensively from now on, so it's good to get some practice in. Our next topic we'll cover is collections using arrays and possibly array lists. So keep your eyes open for that video next week. And I will upload the code examples that I did in this video to my GitHub and to D2L. The link to the GitHub will be in the video description.